Hello everyone, welcome back to another video. In today's video, you will explore the concept of file types and their practical applications. By the conclusion, you will have a clear understanding of what each file type represents, along with the appropriate tools required to access, interpret, and manage them effectively. Let's start with structured files. Think of these as the neat freaks of the data world. They have a well-defined structure, can be stored in schemas, and are usually represented in rows and columns. Structured data is basically facts and numbers, easy to collect, export, and organize in databases. Examples include SQL databases, spreadsheets, online forms, even sensor data like GPS, and network or web server logs. If you've ever worked with Excel or SQL, you've already handled structured data. Now, what about semi-structured files? These are a little more flexible. They have some organizational properties, but they don't fit neatly into rows and columns. Instead, they use tags, elements, or metadata to organize data in a hierarchy. Examples include emails, XML and JSON files, zipped files, TCP/IP packets, and even binary executables. XML and JSON are especially popular because they let you define your own tags and attributes. That's why they're widely used for storing and exchanging data between systems. Finally, let's talk about unstructured files. These are the wild ones. No fixed schema, no neat rows and columns, and no strict rules. Examples include web pages, social media feeds, images, videos, audio files, PDFs, PowerPoint presentations, media logs, surveys. Basically, anything that doesn't fit into a database table. Unstructured data can still be stored in Word docs, PDFs, or even NoSQL databases. But analyzing it often requires advanced tools like NLP, image recognition, or big data pipelines. Before you can analyze data, you need to find it, organize it, and manage it. And that's where File Explorer becomes your best friend. Think of it as the control room for all your datasets, scripts, and reports. Why File Explorer matters in data analytics. Central Hub. It's where all your raw data, cleaned files, and outputs are stored. Quick navigation helps you jump between CSVs, Excel sheets, JSON files, and scripts without losing track. Metadata at a glance. File size, type, and modified date give you instant context about your datasets. Now let's zoom out and look at file types in general. Here are some common categories you'll run into. 1. When you come across text files like .txt, .md, or .csv, think of them as plain or structured text, simple notes, or neatly arranged data. 2. Document files such as .docx, .pdf, or .pptx are what we usually use for formatted reports, ebooks, or presentations. 3. Then we have image files like .jpg, .png, or .gif, which store photos, graphics, and even little animations. 4. For sound audio files like .mp3, .wav, or .aac, hold music, voice notes, or recordings. 5. When it comes to motion, video files like .mp4, .avi, or .mkv capture moving images and full movies. 6. Executable files like .exe, .bat are the ones that actually run programs on your computer. 7. If you're dealing with data files like .json, .xml, .db, or .xlsx, these are structured or semi-structured containers for information, often used by apps and databases. 8. And finally, compressed files like .zip, .rar, and .7z are bundles of files packed together, making them smaller and easier to share. CSVs and comma-separated values files are the simplest way to share tabular data. They're lightweight, human-readable, and almost every tool, from Excel to Python, can open them. That's why analysts often use CSVs for quick exports, imports, or when collaborating across different platforms. JSON, JavaScript Object Notation, is the go to format for web APIs. When apps talk to each other, say a weather app fetching live temperature data, it's usually in JSON. Its key value structure makes it easy for machines to parse and humans to read, which is why it dominates modern data exchange on the web. Parquet for big data pipelines. When you're working with massive datasets in Hadoop, Spark, or cloud data lakes, formats like Parquet shine. They're columnar storage formats, meaning they store data by columns instead of rows. This makes queries faster and storage more efficient, ideal for analytics at scale. Database dumps, .sql.db for migrations. When moving data between databases or creating backups, you'll often see .sql or .db files. These are database dump snapshots of entire databases, including tables and sometimes schema definitions. They're essential for migrations, disaster recovery, or setting up test environments. So why does all this matter? Because the file type you choose directly impacts how data is stored, shared, analyzed, and used. Choosing the right file type helps in better data management, efficient processing, and scalability. If you found this breakdown helpful, hit that like button, subscribe for more beginner-friendly tech explainers, and let me know in the comments. Which type of data do you work with most? Structured, semi-structured, or unstructured? Thanks for watching, and I'll see you in the next one.